Good day to you, awesome grade 9s, and welcome to our WorksheetCloud Natural Sciences lesson. If you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com. And welcome to each and every one of you. I'm absolutely delighted that you are able to join our lesson today. And I am Mrs. Ernston, the WorksheetCloud Grade 9 Natural Sciences teacher. Hopefully you've got your notes and books ready and you've got some paper and a pen and pencil to write with while we work through today's lesson. So we're going to continue having a look at acids and bases and pH, and today's lesson is going to focus on the use of chemical indicators. And we're going to have a look at the use of universal indicator, litmus paper, red cabbage water, and items that you can find around the house or in school laboratories. And we are going to see how they can tell us whether a substance is an acid or a base or neutral. So I would like you to have a look at the pictures that I've put in the screen in front of you. And I would like to see if you are able to give this entire page a title. And if you did have to give it a title, what title would it be? So I'll give you a few minutes to think about your answer. Okay, so let's start with what we know. So let's start here with the car. That light on the car, this part of the car is shining red. So if you see this, it is probably the indicator of the car that is flashing. And if it is only flashing on the one side, that driver of the car is indicating to us that he would like to turn right. We also have a lamp here, and that lamp is red, and that warning light or color, often we associate red with warning. If something is flashing red, it is telling us something. It's warning us about something. It is indicating that something might be wrong. Here is a green arrow, so green could be go. The arrow is also pointing to the right, so the arrow is directing us. It is indicating to us whether or not we can go and if we are allowed to go in which direction. Here, this traffic light is indicating to us that we are able to go. It is flashing green, and we have learned that the flashing green light means we can go, so it is indicating that we can go. This little smile emoji is an indication that you are happy. Here we have a whole lot of different measurements that could indicate various things. So there could be car speedometers, there could be barometers, there could be thermometers, there could be compass bearings. But these are all different items that will indicate something to us. They will give an indication of the pressure or of the temperature or of the direction. Now I wonder if these bottom pictures you've come across before. This bottom one is a universal color pH chart, and it's got numbers 4, 5, 6, 7, 8, 9, and it's got colors red, orange, yellow, green, blue, and purple, and it's got words that mean acid and neutral and base. So stay with me and let's see what the universal indicators are telling us. So I wish I could hear what your answers are for the topic of this slide, but the thought that I had in mind for this was indicators. Everything here is indicating us. Everything here is telling us something. So I wonder if me and you were thinking alike. So what is an acid-base indicator? Some substances change color when they react with an acid or a base. These substances are called acid-base indicators. And they can show us and tell us if a substance is an acid or a base. And different indicators change color at different pHs. And if you've just joined our lesson today, after this video, please go on over to our previous lesson. That was an introduction to acids and bases and pH. So here we have a table that summarizes the different indicators that you might have covered in matter and materials in previous grades. And we will have a look at some of those indicators in our lessons. And that's in our first column. Then in our second column, we've got what color does it go in an acid, and a reminder that anything acidic is pH 1 to 7 or 1 to 6. Then what is the color at a pH 7? So what will the color of that indicator be in a neutral substance or a neutral aqueous solution? And the last column is the color of the base, or the color in a base. So this is going to be pH. If 7 is neutral, it will be 8 to 14. What color will the indicator turn if our aqueous solution is a base? So we can see that our different indicators turn a variety of different colors. So red cabbage water can go reds and pinks in an acid, purple in neutral, and blues or greens or yellows in a base. If you use red onion water, it can go red in an acid, violet in neutral, and green in a base. Turmeric in water is just got 2 color changes. So turmeric is distinctive as a base, it goes red. But otherwise, in neutral or acid, it remains yellow. Phenolphthalein, which you will find in a lab, also just changes 1 color. It exists as a transparent color. It's colorless, but if you add it to a base, it goes a pinky red color. Bromothymol blue changes 3 different colors. In an acid, it's yellow. In neutral, it's green, and in a base, it's blue. You might have come across litmus paper, and we have 2 different color litmus papers, red litmus paper and blue litmus paper. So litmus paper, in both cases, whether it's red or blue, whichever one you are using, but litmus paper goes red in an acid, and it goes blue in a base. So we don't often use litmus paper to determine whether something is neutral. So we just use litmus paper to determine whether or not it's acidic or basic. And then we have universal indicator, and in an acid that goes red, orange, or yellow. Neutral, it goes green, and in a base, it goes blue, violet, or purple. So what is interesting here is these top 3, red cabbage, red onion, and turmeric. You will find these products at home, possibly in your kitchen. And I wonder if you are going to have some fun this weekend or in the following weeks experimenting and playing around and trying to make your own red cabbage juice or your own red onion water or your own turmeric water, and see if you can make your own acid-base indicators at home. I will also be looking at red cabbage water in today's lesson and in future lessons. And then in our science lab, we will find phenolphthalein, bromothymol blue, red and blue litmus paper, and universal indicator. So these are the indicators that you are expected to learn and know in grade 9. So we are going to watch a short video clip now, and while we are watching, I would like you to try and answer what pH are each of these substances, A, B, and C. So I wonder if watching the video you were able to work out what substances were A, B, and C. So if red cabbage water is mixed with a base, it will look like A. It will go a bluey greeny color. If red cabbage water is mixed with an acid, it will look like B. It will go a pinky red color. And it remains a bluey color when mixed with a neutral solution. So you may recall that somewhere along the line in your school career, you also learnt about litmus paper. It is probably one of the most widely used acid-base indicators. Can you find litmus on the table of indicators below? So here it is. So this is what red litmus paper looks like. So it's actually not a bright red at all. It's like a pinky orangey color, but we refer to it as red. And that is what blue litmus paper looks like. So litmus does not change color in the presence of a neutral substance. So we don't use litmus paper to test whether or not a substance is neutral. We only use red and blue litmus paper to test if the aqueous solution present is acid or base. And we test it the following way. The litmus paper is red in the presence of an acid, and the litmus paper is blue in the presence of a base. Litmus paper can also be bought as a solution, and you can also find it as paper. So we have learnt so far that indicators change different colors in the presence of an acid or a base. And indicators can show us whether or not a substance is an acid or a base. And we've seen this using litmus paper and red cabbage juice. So as you saw in the previous diagram, universal indicator can show us much more accurately how acidic or basic a solution is. So can you find universal indicator on the table below? Yes, it's right here at the bottom. So universal indicator is able to change across a wide range of colors, very similar in actual fact to red cabbage water. So universal indicator can change into a whole range of colors depending on the pH of the solution. So in the following picture, solutions of increasing pH were mixed with universal indicator to show its full range of colors. And the diagram on the left here can show us the pH range from 0 to 14 and what different substances we find and what colors they turn. So for example, gastric acid is a pH 1, so the solution will be red. Lemon juice will be orange. Orange juice will be a yellowy color. Tomato, yellow, green. Coffee, green, yellow. Urine is green. Distilled water is blue. Seawater is blue, purple. Baking soda is a mauve, lilac. Milk of magnesia is a purple, pink. Ammonia solution is a cerise pink. Soapy water is dark pink. And then bleach will be red. So universal indicator can have many different colors, from red for strong acids to dark purple for strong bases. The liquid inside the middle test tube is pH 7, and this is shown by the green color. So if we go through that again, acids will be red. Bases are generally purple. So acids are things like your gastric juice and lemon juice, and bases are things like bleach and ammonia. And then anything that is neutral will be indicated by a green color. So universal indicators give a range of colors that can be used to determine the pH of a solution. And we can find a universal indicator as a liquid, but we can also use universal indicator paper. Now, how does the use of universal indicator compare with the use of litmus paper? So litmus paper can only tell us whether a substance is acidic or basic. A reminder, we don't really use it to test whether or not a substance is neutral. Whereas the indicator can actually give us a specific pH on the scale from 1 all the way through to 14. So like litmus, universal indicator also comes in paper form with a pH color range of the indicator printed on the packaging. The advantage of using universal indicator over other indicators is that universal indicator can give us a much more accurate pH measurement. So not just whether something is an acid or a base or neutral. This is because it has many different colors for different pH values. So every different pH value has a color, whereas most other indicators change only once or twice across the entire pH range. So how else can we measure pH? So scientists use a pH measure to quickly and accurately measure the pH of a substance. So while they are much more expensive to purchase than the indicator paper or solution, they are a really worthwhile investment in a laboratory because you are able to make accurate pH measurements daily and quickly. So a pH meter is an electronic instrument, and it has special sensors at the end that are sensitive to acids and bases. And obviously the use of this equipment is far more accurate than universal indicator paper or litmus paper. So I hope you are able to have some fun after this lesson and explore what items around the house can you use to make some colorful acid-base indicators. And check out the diagram below and see if you can make some of these at home. So you can try using beetroot or cherries, maybe even try curry powder, grape juice, onion, peach skin, tomatoes, turnip, and I know that even tea can sometimes work as an acid-base indicator. So I hope you go and have some fun at home making acid-base indicators. And remember, there are lots of aqueous items around the house that you can use. So for example, normal tap water, vinegar, ammonia can be used to test your acid-base indicators. So I hope you have fun, and I look forward to hearing all about your explorations in the kitchen. So what have you learned today? Well, let's do a 3, 2, 1 activity. Why don't you write down 3 things you discovered? So information that you have not learned before. How about 2 interesting facts or details that you can remember? And 1 question that you may still have. And you can email your questions to grade9@worksheetcloud.com. We look forward to hearing from you, and I look forward to seeing you in future lessons. So grade 8, this lesson would not be possible without you out there listening to these lessons. So thank you so much for joining us today. And even a bigger thank you to Worksheet Cloud for bringing this lesson to you. So cheerio grade 9s, and I look forward to seeing you in the next lesson. Bye.